Welcome to XNA Tutorial 3, C# syntax. And we talked a little bit about variables and methods last time. And first thing before we go into this tutorial, I'm going to talk about two things I forgot: assignment statement and returning method. And then after that we'll go into parameters and arguments, method overloading, loops, decision, maybe, probably not in this tutorial. That'll be on next tutorial. Okay, so let's go and talk about the assignment statement right now. We talked about variables last time, and the variable is equal to a number, 20, 30. And what I didn't explain to you what an assignment statement is, I had that in a slide, but I didn't explain it in great detail. So a variable is equal to an expression. This will assign an expression to a variable. And both types, both sides of the equals have to be matched. Like you can't say int x is equal to true or int x is equal to 33.2 or something like that. You have to have both sides matched. Since true is a Boolean value and 33.2 is a double value, it can't be stored in an integer. So both types have to be matched. The equals you see here is an assignment operator. And later in this tutorial, you'll see two equal signs right next to each other, double equals, and that is a logical operator for equal to. So what can be an expression? An expression can be a constant, which is a number, true, false, a character, a variable, which can be int x is equal to y, and y is something else you assigned it to, a returning method, that's underlined because it will go into that a few slides later on, or a combination of the above with math operators in between, like int x is equal to 3 plus 5, int y is equal to 3 divided by 2, stuff like that. So let's talk about returning methods. Returning methods are what they sound like, methods that return a value. Since a returning method returns something, we need to have a variable to hold that data. This variable is commonly known as a catcher. So the returning method call looks something like this: variable is equal to returning method, and then parentheses, semicolon. So a returning method is basically what we covered last time, except it returns a value and you need a variable to catch that value. And then you need a return statement, which I'll go into in the coding. Okay, parameters and arguments. Parameters are locally defined variables inside of a method header. In between the parentheses, that's called a method header. And these variables are local only, meaning you cannot access them in a different method or outside of that method. And you can have int x in 27 methods, or an infinite amount of methods. You can have int x in all those methods and it will still work. Arguments are the opposite. These are values or variables you pass to those parameters. So that's inside the call statement. You put these arguments. You need an equal amount of arguments and parameters, and the types have to be matched. You can't send a true value when it's expecting an integer value. Okay, here's an example of a parameter. We have public static int. This returns an integer value. Then the method name, I called it decrease health, and I send it health, a health value, and it makes a parameter locally defined variable health of type int. So what I can do now is I can use that inside of this method. I use it right here and I return it right here. So I can say health is equal to health minus 1. And then I return that health back again to the catcher. When I return that value or variable, I need to have a catcher to catch that value or variable's contents. So here's an example of an argument. So inside of the main method, let's say I make an int health is equal to 100. Then I have a variable to catch that value. So health is equal to decrease health, parenthesis, and I send that, that's an argument, I send that variable or value to the decrease health. So I'll go demonstrate that right now. Again, this is a console application. You can get there from File, New Project, selecting console application, and typing in the name of the namespace you want. Okay, so we have a main method, so I'm going to make an int health is equal to 100. And I'm going to finish the main method, so I'll just say health is equal to decrease health, and then I'll send it the health. And as you can see, that purple rectangle underneath the D, I hover over that and I get this option to create it. And then it automatically creates int return type, and it created the parameter for me. So now all I need to do is implement the information in here. And I'm going to change this to public because you're used to that. So now I'll just say health is equal to health minus 1. Then return health. Okay. So after that gets done, I'm going to do console.writeLine. And I'm just going to print out health is equal to, end quote, plus health.toString. Then I'm going to have console.readKey to wait for the user to press the key. Okay, so now I press F5 to compile and run this, and it shows that health is equal to 99. Okay, so now let's walk through the debugger, because you see the code, but you probably don't know how it works. So let's add a line break in right here. I press F5 and it'll stop right there. So right now, you'll see at the bottom a locals section. If you don't know that, just click locals. And then health is right there. It made health, but it didn't set the value yet. I do step into, and now the value is at 100. I step into again. See, that value is 100, and then that value is 100. These are two different variables. Remember that. If I change one, it won't affect this one. A better demonstration would be like this. Int new health. Actually, I'll just call it right there. Okay. So now I have two variables, and I'm going to add more here. New health is equal to plus new health dot toString. Okay. So now I have two different variables. I have a health and a new health. This to show you that these two variables will be different. Health is equal to 100, new health is equal to 99. Okay, now I'll do the line break and walk you through it again. Okay, we were inside of here. Okay, I send health, and that value is copied to this health. The name is the same, but there are two different variables. Now I decrease this health, by 1. Not this health. I don't touch this health. And once I do that, you'll see the health value decrease down here. It goes down to 99. Now I return that, and that is stored inside the catcher, which I named it new health. New health has nothing in there yet. You can see that by down here, say new health 0. Then I step into again, and it sets it at 99. Remember, health is still at 100. Now I print it out, and everything's fine. So that's how to pass things from one to another. You can pass unlimited amount of stuff. Like I can have int x is equal to 3, int y is equal to 5, and of course you can bypass certain steps. So if I just want to say, I'm going to get rid of this method right here. I just want to print out the addition of these two variables. So without storing them in a different variable, I can bypass that and just say add right there. Then I pass it x comma y. And then I end the parenthesis, and that will work. And then I generate it, and it says it returns a string, but you don't really need to. I change it to int, and I'm returning x plus y. And of course I can do the dot and do toString, or you don't need to do that. So that will return 3 plus 5, which is 8. So you can bypass that. You don't need to store it in a different variable. If you have lots of memory using up and you want to decrease the amount of memory being used by your program, you can do stuff this way, but either way is fine. And again, I bypass this step right here. I didn't store that in another variable. You return an expression, and you can go back in the slides to see what an expression is. Variable, or a combination of the above with math operations in between. So I do variable, math operation, variable. Variable, math operation, variable. So I return an expression. Okay, so now let's talk about method overloading. Method overloading is making a method with the same name and return type as another method. The reason this works is because it has different parameters, so it can distinguish which method you're calling. So I'll just use this add as an example, and then I'll have an int z is equal to 8 for an example. And I'm gonna change the right line to quote x plus y is equal to end quote space plus space add x comma y. Now I'm going to make another right line, and I'm going to do this way. X plus y plus z is equal to quote space plus space add. Then I put 3 variables in there. X comma y comma z, and that method is not known by the compiler. As you can see, the purple rectangle underneath the A. Then I'll do dot toString, and then I have the program generate it for me, and then it says it returns an object, and then I'll change that to int. Return x plus y plus z. So now I need another parenthesis. So now I have 2 different methods with the same name, same private change that to public. Same access modifiers, and same return type, same everything except for one additional parameter, and this is allowed in programming. This is called method overloading. And now when you call them with the code completion, you do add, you get one of two. Then it can go up and down and see, oh, this one accepts a Z parameter and this one just accepts an X and Y. So we compile it and run it when we see X plus Y is equal to 8. X plus Y plus Z is equal to 16. I've seen some programs have about 7 or 8 different methods that overload each other. And I don't really think there's a limit on those, so you can have as many as you wish. But don't go crazy saying XYZ and then go to add like 500 different things. Now let's talk about Boolean operators. We have many different operators for Boolean expressions. We'll go into Boolean expressions in the next slide. The double ampersand operator means and all comparisons must be true. I'll use the if statement as an example because that's easily to relate to English. So if I go to the mall and I have money, I will buy something. If I don't go to the mall and I have money in my pocket, I'm not going to buy anything. But if I do go to the mall and I don't have money, I'm not going to buy anything. So both of them have to be true in order for me to buy something. The or, the double vertical line, that's the key above your enter, right by the slash. The double vertical bar means or, and one of those comparisons must be true. This or that. One of them can be false, but one of them has to be true for this whole statement to be true. Exclamation point, this means not. So if you have an expression and you put an exclamation point in front of it, you're saying this is not, it's going to reverse it. If the expression returns true, the not will make it false. If the expression returns false, the not will make it true. Exclamation point equals. This stands for not equal to. So you can have if x exclamation point equals y, that's equivalent to x is not equal to y. Here's the double equals. That is equivalent to equal to in programming. You could say x is equal to double equals to y, and that will compare if x is equal to y, it'll return true. Then of course we have the basic math, greater than, less than, greater than or equal to, less than or equal to. You're all familiar with those. Boolean expression. A Boolean expression, or a condition, as some programmers call it, is a combination of expressions and Boolean operators. So you can have expression, Boolean operator, expression, Boolean operator, and stuff. It can go on forever. Okay, so now loops. First is a while loop. And it does what it says, while Boolean expression. The Boolean expression must evaluate to true in order for the code inside the curly braces to execute. So while the Boolean expression is true, the code inside here will loop. I'm going to demonstrate the while before I go into the for. Okay. So int x is equal to 0. While x is less than 10. This is true because x is 0. It is less than 10. So the code in here will evaluate. or execute. And I'm just going to have it say right line x is equal to end quote plus x.toString. And there's a problem with this code. If I run it now, I'll get an infinite loop. You need to make sure you check things before you run codes with loops, because it can get an infinite loop and you'll have to go into your task manager and quit or do something to get rid of it. So make sure you ask yourself before you run the program, is there any way that this can become false? And right now, no, there is not, because I do not do anything with x. So I just do x is equal to x plus 1. So that'll increase x every loop until it reaches 10, then it will quit. And I'll demonstrate that by doing a right line here. End of loop. X is equal to quote plus x.toString. Okay, compile it and run it. So now we're looping. X is equal to 0, that's the first loop. And then it keeps on doing that. End of loop, x is equal to 10. Because 10 is not less than 10. It equals 10, but it's not less than 10. If you want to do that until it equals 10, do less than or equal to. So now let's do line break. Right there. Or a breakpoint. Now we run it and we're now debugging. So we step into and it sets x is equal to 0. Now we entered the while loop. X is equal to 0 and it evaluates to see if this is true or false. If it's true, we go inside the block. Now we write to the monitor, increase x by 1. And watch down here when I do step into. X becomes 1. Then it checks it again, see if it's true or false. If it's true, it goes inside the block. Then it repeats. And I'll check it again, checking again, checking again. Okay, now x is 10. It's checking again if it's true or false. Since 10 is not less than 10, it evaluates to false. If it's false, it will not go inside the block and the program will continue down to the next line. So that's how loops work. It loops until the condition becomes false and then it will resume the rest of the program. And there we go. Be careful you don't have too many big loops, because a loop is what it does. It'll loop the program and your CPU will go up. So now let's look at the for loop. Whatever is in light blue in between the less than and greater than are optional. So let's look at the for loop. We have a for, that's a C# keyword. That should be in blue, but anyway. We have a for, and then an opening parenthesis. Then we have initialization. This is optional part of the code. Then we have a semicolon. This is not optional. Then we have a Boolean expression. This is optional. Then we have a semicolon. This is not optional. Then we have a post body action. This is optional. So let's go back and look at down here. Initialization. This part is optional, and we use this to initialize a variable that you can use in the for loop. So we have another locally declared variable. The Boolean expression, this is like the while section inside the while loop. This part is also optional, and just like the while loop, a Boolean expression goes here. Post body action, this is something different in the for loop than you will see in the while loop. Or you won't see in the while loop, but the post body action is the last part of the for loop, and it is also optional. Use this area to perform actions after every loop. Keep in mind that the semicolons are not optional. You need the semicolons. If you want an infinite loop, just do for parenthesis space semicolon, and parenthesis. I'll demonstrate that now. Just like any looping in programming, you can convert between the while, do while, and for. I'm not going to go into do while because that's kind of weird loop. But anything you have as a loop, you can convert to a different type of loop. So we can translate this while loop into a for loop. And I'm going to do that above it. For, parenthesis, at the very beginning, we need an initialization. So just cut this or move it down here. Now we have a semicolon there, so that's good. Then we just move this up there. That's our Boolean expression. Now that's good. We need a semicolon. Now goes our post body action. We do not need a semicolon after that. So just move this up there. And a quick tip, x is equal to x plus 1 is the same thing as saying x plus plus. Just a quicker way of writing it. So x plus plus is the same thing as saying x is equal to x plus 1. Then we close the parenthesis and open in the brackets. And now we just copy the contents of our while loop. Tab it. And delete the while loop. So now we just moved from while to for, and it made our coding smaller. But we still get the same effect. So since you've already seen the output, I'm just going to do a line break right here. So F5, build errors. Oh, I see what I did. Okay. Made a mistake of doing that. Because that's locally declared variable. So that's only visible inside of this for loop. Inside of this for loop, it's only visible there. So X does not exist right here. So we don't need an initialization, so that'll be just semicolon. Okay, so now let's do a line break, or breakpoint. Okay, before we have X initialized and set to 0. Now we enter the for loop, it checks the Boolean expression, just like the while loop. And if it's true, we go into the coding, or go into the body of the loop. And then after that gets finished, we go into the post body section. And then after that, we go into our Boolean expression section again. And that will repeat until the Boolean expression is false. And once it's false, it'll exit just like the while loop, and your looping will be done. Now there's one more loop that I will not go into this tutorial, but I'll go into during the XNA series, or next tutorial, whichever one feels more fit. And it's called the for each loop. If you wish to learn about it now, you can go into Google C# for each, and you'll get the MSDN documentation for the for each loop. But I'll go into that either next tutorial when we talk about OOP, because that's what you'll use it mostly for, or I'll go into it on the future tutorials. So next tutorial I'll only cover one thing, but that one thing is a pretty big topic, so that'll be about 30 minutes of OOP talk. Hope to see you next time.